for interest, we will learn that there are two types of interest, the simple interest and the compound interest. So there's a reason why it's being called a simple interest because it's really simple. The idea here is that once, for example, for this one, okay, for example, if you deposit a $3,000 in a bank at an simple interest rate of 2% per annum, means every year they give you 2% of what you have initially deposited. That means the interest, this percent, is always based on the amount, the initial amount that was deposited. So no matter how many years you put it, every year you will just get this fixed amount of $60. Okay, so that means 1 year, the first year you will get $60. Okay, so for simple interest, yeah, always forget to click this. Okay, okay, so for first year, for simple interest, you can think of it as like a fixed amount. Meaning the 2% interest here in this example is $60, right? So first year you get $60. Second year you'll still get $60. So in order to calculate total interest, it will just be 60 times X. So where total interest in X number of years. Okay, so after 10 years, you just have the interest that you get is just 60 times 10, which is $600. So the idea of simple interest is pretty easy, it's simple. Then we'll move on to compound interest. Compound interest is slightly more complicated, but it's still manageable. And compound interest is what Warren Buffett thinks as the best way, okay, or the understated way of accumulating wealth. So let's see how compound interest works. Let's find an example here, shall we? Okay, this one, the formula will do it later. So let's look at try it 19. Farah borrows $1,500 from a bank at a rate of 10% per annum compound interest. Wow. So you want to find the total interest accumulated, and it's never a good idea to borrow money under compound interest. Let's see why. So for the principal amount that she has, at the beginning, she owes 1,500. At the end of the first year, it will be 1,500 plus whatever she has owed, which is 10% of 1,500. Okay, so let's simplify this. This is 1 unit of 1,500 plus a 0.1 of 1,500. So this is, we add up to a 1.1 times 1,500, right? So 1,500 plus a 0.1 of 1,500, total 1.1 times 1,500. This will be the total O after first year. In the second year, what she will owe will be this amount. This is now the new principal amount, and on top of that, she's going to accumulate 10%. So whatever you owe here, the original amount, and on top of that, we're going to add a 10% to this. Right? So this is the amount she owed the first year. Let's bring it down here. The amount that she already owed and 10% on top of the amount that she owed. Okay, so this is what she owed at the end of the second year. maybe we can simplify this a little. Let's factorize out this 1.1, 1500. So we factorize out this. What we're going to have left is a 1 plus 0.1, right? So there's a 1 unit here. So we factorize out. So this is like our x now. Okay, so after we factorize out our x, what we have left is a 1 unit 1 plus a 1.1. So what we have here is a 1.1 times 1500 plus a 1.1. So what do you see here is a 1.1 square, right, times 1500. See that? Okay, so you can always look at your principal amount as this number x here. So this is a x plus a 0.1x. So in the case where you have a, let's use another color. So in the case of where you have an x plus a 0.1x, you can factorize out your x and you're going to get a 1 plus 1.1 plus 0.1 left behind, right? Okay, so you're going to have a x times 1 plus 1. You should be able to get this. Once you factorize out x, you get a 1 plus 0.1. So you get a 1.1x. Okay, which is what we get here. This is our 1.1. This is our x and this is our 1.1. So now let's go back to this. After second year, this is what we get. So this is our new principal amount. Then now you want to get a third year. So you want to see what you get in your third year. So let's do this again. At the end of your third year, you will have what you have already accumulated in your second year. This is the amount that you owe in the second year. On top of that, another 0.1% from your second year. Okay. Don't worry, it may look complicated now, but we're going to see that there will be a pattern coming out, which will eventually generalize into the formula that your textbook shows. So over here, you have this 1.1 square times 1500. This is the amount, the principal amount now you owe after second year. And on top of that, there's a 0.1, which is a 10% on top of the second year. So this is your interest. This will be your interest at the end of third year. Let's simplify this. Again, we factorize out this. Do you see this is the common factor that we can factorize out? This is a common term here. We factorize out 1.1 square times 1500. And what is left behind is this 1 unit here. Okay, once you factorize out this, you will not get 0, you get a 1 left behind. Okay, this is what we have been emphasizing in Sec 2 maths. Once you factorize out, for example, you factorize out x, what is left behind is a 1. This one, once you factorize out this term, you are left behind with a 0.1. Okay, I hope you are seeing the pattern now. So this is a 1.1 square, 1500. And in this bracket here, we have a 1.1. So now we have a 1.1 cubed times 1500. Okay, so do we see the pattern here? So you can calculate this will be the total amount that she owed at the end of third year, but the question is asking for two things. The total amount she owed, so the answer that we have at the end here, this will answer that the total amount that she owed, and the total interest accumulated. That means you have to minus away, use this answer, minus away 1500, and you will get your final answer. Let's come back to this. So if you see the pattern just now, right? Do you see? Let's recap. So for just now that question, what we have is towards the end of the third year, Okay, the total interest that she owed was 1.1 cube times 1,500. Correct? So let's generalize. This was the principal amount. Correct? And this 0.1 here was the 10% interest. And this cube here was the number of years that she owed the money already. Correct? So 3 years. So we are able to see that it corresponds with this compound interest formula where, see, here is your principal amount, 1,500. Okay, and will be the number of years that she has already owed. So just now we were talking about 3 years, at the end of 3 years, so we have a cube here. 1 is because, as you see, the 1,500 we just keep bringing it down, right? So we have this 1 plus the interest that we're talking about. So it was the 10%. So it's you either write 1.1, 0.1 here, or you write 10 over 100. Okay, so there we have our compound interest formula. So if you have understood the compound interest formula, let's go to try it 20. What we have here is the total sum, just going to use black here, the total sum of 8,400 invested at interest rate of 9% per annum for 6 years. And find the total interest accumulated if it's compounded yearly versus monthly. So for 20A, suppose it's compounded yearly at the end of 6 years. So you have just now the formula. Remember? So you have the principal amount, which is 8,400 at the beginning. Your interest rate is 9%, so it's 9 over 100 times to the power of 6 years. So if you key this in your calculator, you will have the total amount. But the question is tricky. I mean, students always get tricked at this kind of question because you will just stop here. You will just say the answer is 14087.64 to 2 dp. But you shouldn't stop here because they're asking for the total interest accumulated. They want the interest, not the total sum. So the interest accumulated, you got to use this, whatever you have here. Okay, whatever the total amount left in your bank, minus away the initial principal amount. So you have here 5687.64. This is the interest accumulated. Okay, so after 6 years, you just put your money there, you earn 5,600. Not too bad. Now you want to calculate this monthly. So how do we do that? Note here that it is 9% per annum, right? So we calculate here per annum, 9%. Per month will be 9 divided by 12. It will be a 0.75%. Okay, so 0.75 per month. Then we calculate as usual. So we have 6 years. We need to know 6 years is how many months. So that will be 72 months. So let's start on our calculations now. Principal amount, remember, let's just recap this. So we treat it as 8,400, 1 plus 0.75 over 100 72 months. This will be the number of times it's going to repeat, like the cycle. Okay, so there are 72 cycles, right? In this case, we are working in terms of months. So 72 months. Each month, your interest is 0.75%. So let's calculate here, 0.75. There you have it. You're going to get 14385.44. So total interest 14385.44 minus away. Okay, sorry, I forgot this. Too deep. Minus away 8,400. You're going to get 5985.44. Now this question is interesting. So this is a little bit of the reverse engineering. A company took up a loan, 9% per annum, compound interest. The final loan became 80,000 after 6 years. So what's the original loan amount? So let's look at the formula that we have learned. This will give you the total amount. But what do we know? We know that P is what we want to find, which is the original loan amount, the principal amount. And the interest was 9% per annum after 6 years. So number of cycles, 6 cycles. How do we solve this? So you want to find the principal amount. You will just use 80,000. This is a multiplication, right? So if I want to shift this whole thing over to the other side, it will be a divide away. You want to divide this away. Okay, so you just have to key this in your calculator. Divide by 1 plus 9 over 100 power of 6. So what you have here is 47.39 true 2dp. So this was the original loan amount, and then it snowballed after 6 years to 80,000.